Hello everybody, welcome into another lesson. So today we're going to talk a little bit more about sort of circumference and then areas of circles, but what we're going to talk about is the length of arcs of a circle and the area of a sector of a circle. So up here you have, of course, the shaded region inside of circle O, with O being the center. You have arc AB, and then, of course, the arc has a measure of 90 degrees. So you can think of this arc, 90 degrees, as part of the circle. It's part of the circle. That's what we're going to try to find. To find the length of the arc of a circle, you take the number of degrees the arc is over 360 degrees, because you think about it, it's a certain number out of 360. You take that times 2 pi r. So it's the number of degrees out of 360 times the formula for the circumference of a circle. So basically you're finding a mini circumference, if you will. That's the length of an arc. And up here, for example, this is a 90-degree arc. So the length of arc AB, in this case, you would take 90 degrees out of 360 degrees, multiply that by 2 pi times that radius of 5. This would, 90 out of 360 turns into 1/4 of the circle. So that's 1/4 times 10 pi, which would give you an area for the sector of 5 pi over 2. And today we're just going to leave everything in terms of pi. I trust everyone knows how to put pi in a calculator and get a decimal by now. So if you're curious what that really looks like, just put it in the calculator and you'll get it. So the length of this arc would be 5 pi over 2. Then, like the length of the arc, we have the area of the sector. This whole shaded region that intercepts the arc is called a sector of the circle. To find the area of the sector, you still, once again, you'll take the number of degrees out of 360, you'll multiply that by pi r squared, which is the formula for an area of a circle. So you're finding a mini area of a circle, an area for only part of the circle, if you will. So in this case, to find the area of sector AOB, which is the shaded region, you're going to take that 90 degrees out of 360, multiply that by pi times your radius of 5 to the second power, which 90 out of 360 turns into 1/4, then times 25 pi, giving you an area of 25 pi over 4 for the sector. And again, if you're curious what that looks like, put it into your calculator, you'll get a decimal approximation. So that's how we're going to, that's what we're going to do today. Should be a few problems here. This shouldn't be a super terribly long lesson. It might go a little bit longer than yesterday's, but my goal is not to make this a long lesson, of course. That's really not my goal. I'll just have to redraw part of the circle. It's quicker that way. There we go. Okay. So all these exercises are going to be today is finding the arc length, the length of the arc rather, and then we'll find the area of the sector, okay? So let's do another example here. Let's say, in this particular case, you have a radius of 12. So the radius is going to be 12, and it forms a 30-degree angle. So this would be, of course, point A. This will be point B. And then we want to find the length of arc AB. We also want to find the area of sector AOB. So I'm going to shade in the region that we wish to find, which will be that piece right there. And they give us that the measure of arc AB is 30 degrees. Well, we can start by finding the length of the arc. So to find the length of the arc, the length of arc AB, that's going to be equal to the measure of your arc, which in this case is 30 degrees, out of the whole 360 degrees, times the formula for the circumference of the circle, which would be 2 pi r, which in this case the radius is 12, so it would be 2 pi times 12, which 30 out of 360 is 1/12, so that's 1/12 of the circle, times your times this here, the 2 pi times 12, so that'd be times 24 pi, which when this simplifies would give you the length of your arc AB being 2 pi. So the length of arc AB would end up being 2 pi. Now we of course can go on to find the area of sector AOB. So to find the area of AOB, that's equal to, of course, once again, your 30 degrees out of 360 degrees times the formula for the area of a circle, which would be pi r squared. In this case, your radius is 12, so that would be 12 to the second power, which we know 30 out of 360 again is 1/12, times the pi times 12 squared, that'd be times 144 pi, which when simplified would give you the area of sector AOB being 12 pi. So for this one here, you should get the length of arc AB being 2 pi, the area of sector AOB being 12 pi. Alright, what's next here? Let's do the next one. And let's make the circle a little bit better, shall we? Okay. Circle O, of course. In this case, we are given a radius of 4. So the radius is 4. This is going to form, I'll give it to you here in a second once I label the points. Let me shade in the region here, of course. Alright, they give you that the measure of arc AB in this case is going to be 45 degrees. So we have arc AB that's 45 degrees. First, let's find the arc length of AB. So the length of arc AB, whoops, I almost said segment AB, excuse me. This needs to be arc AB. That's equal to, of course, the number of degrees of the arc, which in this case is 45 degrees, out of 360 degrees, times the formula for the circumference of a circle, which would be 2 pi, times your radius of 4, which would end up giving you 45 out of 360. That's actually 1/8. So that's 1/8 of a circle times 2 pi times 4, that'd be times 8 pi, which would give you the length of arc AB just being pi. So the length of arc AB itself is going to be pi. Now we need to find the the area of sector AOB. So we'll do that next. So the area of AOB, this is where it gets a little bit more fun since we have something to the second power. So you're going to take again that 45 degrees out of 360 degrees times your pi times that radius squared, which would be 4 to the second power. So 45 out of 360, that's 1/8, times 4 squared is 16 pi, times 16 pi, which when simplified would give you an area for sector AOB being 2 pi square units. So the length of arc AB is pi, the area of sector AOB is 2 pi. Let's see, I'm going to do what? 1, 2, 3, 4 more. I just got 4 more we'll do. Okay. See, we're going to have a radius of 3. This will also be a radius of 3. This will be point A. This will be point B. And yep, we're going to shade this entire region. There we go. This time they give you that the measure of arc AB is going to be 120 degrees. So, we have sector AOB where the measure of arc AB is 120 degrees. We need to find the length of arc AB and the area of sector AOB. So, we'll start with the length of arc AB. So, the length of arc AB, of course, is going to be equal to the measure of your arc, which is 120 degrees, out of 360 degrees, times the formula for the circumference of a circle, which would end up being 2 pi times your radius of 3, which then we know 120 out of 360, that's a third of the circle. So that's going to be 1/3 times 2 pi times 3, that'd be times 6 pi, which in the end would end up giving you the length of arc AB would end up being 2 pi. So the length of arc AB itself is equal to 2 pi in this case. Now we need to find the area of sector AOB. So the area of AOB, that again is equal to the measure of your arc, which would be 120 degrees out of 360 degrees, times the pi r squared formula, In this case, the radius is 3, so that'd be 3 to the second power. Well, 120 out of 360, that's a third. That'd be 1/3. Now 3 squared is 9, so that'd be 1/3 times 9 pi, which would end up giving you that the area of sector AOB is 3 pi. So the length of arc AB is 2 pi. The area of sector AOB is 3 pi in this case. Alright, so then we have, let's see, circle O. Of course, here will be A. This will be B. You'll see what I'm about to do in a minute. Still a radius of 3, but this gets to be a lot of fun. Not going to do the best job coloring because it's such a big area, but all right. That's a big sector to find. They give us that the measure of arc AB is 240 degrees. So now we have to still find the length of arc AB, and we have to find, of course, the area of sector AOB, the 240 degree region, that shaded region. So let's start with the length of AB. The length of arc AB, that of course is going to be equal to your 240 degrees out of 360 degrees times that formula for the circumference of a circle, which would be 2 pi, then times your radius of 3. So 240 out of 360, that's 2/3 of the circle. So we have 2/3 times 2 pi times 3, that'd be 2/3 times 6 pi, which would equal 2/3 times 2 pi. Well, no, that'd equal, the 3 and the 6 cancel out, so that would equal 2 times 2 pi, which would give you the length of arc AB would be 4 pi. So the length of arc AB in this case would end up being 4 pi. Now we need to find the area of sector AOB. So the area of AOB, that's equal to, again, that 240 degrees out of 360 degrees times the formula for the area of a circle, which would be pi times that radius of 3 to the second power. Well, we know 240 out of 360 is 2/3. That would be times, what's 3 to the second power is 9. That'd be times 9 pi, which would turn into 2 times 3 pi, which means the area of sector AOB would end up being 6 pi. So the length of arc AB is 4 pi, the area of sector AOB is 6 pi. I might as well just draw a whole new circle at this point for what I got to do. Should just have 2 more exercises, then we'll be done. Here's still circle O. Alright, then I need to shade this region. Alright, then of course this would be 180 degrees. Alright, so we have again circle O. We would end up having here, of course, arc AB has a measure of 180 degrees, so that's half the circle. Each radius is 1.5. So let's find the length of arc AB. So in this case, the length of arc AB, that's equal to, of course, your 180 degrees, which is the measure of the arc, out of 360 degrees, times your 2 pi times your radius of 1.5. Well, what's 180 out of 360? That's 1/2. So you'd end up having 1/2 times 3 pi, which would simplify into 1.5 pi. So the length of sector AB in this case, the length of, rather, arc AB in this case would be 1.5 pi. Now we can find the area of sector AOB. So the area of AOB is going to be equal to, of course, the 180 degrees out of 360 degrees times the formula for the area of a circle, which would be pi times that radius of 1.5 to the second power. Which then, this of course would turn into 1/2 times, of course, now you have to take 1.5 to the second power. I believe that's 2.25, but let me just double check that. Yep, that'd be 2.25. Pi, which now, of course, we can simplify this a little bit. We can actually get rid of the decimal. It doesn't really matter how you want to do this. If you want to get another decimal, you can divide by 2. You might get several answers that are exactly the same. If we multiply by 2 here, you would end up getting, well, you don't want to do that because that'll change your denominator. So it would be equal to, what is 2.25 divided by 2? We better just do that. It's 1.125. So what you end up getting actually for the length of arc AB is 1.5 pi units, and then for the area of sector AOB you get an area of 1.125 pi square units. So sometimes the area number can be smaller than the length of the arc's number. It can happen. It's not often, but it does happen sometimes. I got just one more, then we're done. Okay, let's draw another circle. Circle O. This, of course, would be A. You'll see what I'm about to do in a second. What is the radius this time? 0.8. Yep, this one's going to be a lot of fun. I think you'll get the idea of what I'm trying to shade here. I'm not going to run out my marker completely like I'm already doing, shading all this, but you'll see the red shaded region is exactly what we're trying to find. Alright, so we have a circle here with radius 0.8. You would have arc AB going this way, which is what we're trying to find. The measure of that arc is actually 270 degrees. We need to find the length of arc AB going this way and the area of sector AOB, the shaded area. So, of course, let's start with our arc length. The length of arc AB is equal to that 270 degree arc measure divided by 360 degrees times the 2 pi times that radius of 0.8, which 270 out of 360, that's going to be 3/4. That's actually going to be 3/4 times, what is 2 pi times 0.8 times 1.6 pi, which would actually be equal to 4.8 pi all over 4, which would be equal to 1.2 pi. So the length of arc AB going this way is 1.2 pi. Now we can find the area of sector AOB. So the area of AOB is equal to, of course, that 270 degrees out of 360 degrees times, in this case, the formula for the area of a circle, which would be pi times that radius of 0.8 to the second power. Well, 270 out of 360, that's 3/4 times, all right, what is 0.8 to the second power? That'd be 0.64 pi. All right, now let's try to get rid of that decimal. That would give you 0.48 pi. So the area of sector AOB in this case would actually be 0.48 pi square units. So that's it for the for the general lengths of arcs and the area of sectors. Next lesson is sort of a part 2 to this. We're going to be given circles and we're going to find the area of a shaded region, but it won't be your normal sectors, but you'll see when we get to that lesson. So I hope everybody has a great night. Take care.